Swayam Prabha. Digital India. Educated India.
Welcome back. In Module 7, we will talk about waste disposal planning for urban areas. And in Lecture 31, we will be talking about Solid Waste Management Rules 2016 and within that, specifications for sanitary landfills. The different concepts that we will cover are on waste disposal at sanitary landfills, landfill and sanitary landfill definitions, the Software Management Rules 2016 and what it talks about sanitary landfills, then Software Management Rules 2016, criteria for site selection for landfills, then criteria for development of facilities at the sanitary landfills, criteria for specifications for landfilling operations and closure, criteria for pollution prevention, criteria for environmental monitoring and also other criteria. So, as we have learnt earlier that when we talk about integrated solid waste, our idea is to reduce the total quantity of waste that finally reaches the landfill. So, of course, we should try to reduce at source and of course reuse as much as possible. Then recycle some of the waste that is generated or some of the, like for example, we can recycle certain materials, certain glass, certain metals can be recycled, some paper can be recycled. Similarly, composting for the biodegradable part, for organic part we can do composting, and then some of the rest could be also converted into energy, some waste can be also converted to energy, and finally whatever remains goes to the landfill site. So, our goal is to reduce in each of these phases and finally when we reach the landfill site it should be as less as possible. Because landfill requires land and in certain areas there is absolutely no land area available where we can permanently put our waste or dump our waste. And as you know that if I design a landfill site, the site life is for a long period and that means that that particular area would be engaged. And so, we cannot have other alternative uses for that area for a long period of time. So, areas which do not have land, there of course the target should be to reduce as much as waste that goes into the landfill that reduces the overall area for the landfill site. So, usually we should avoid sending biodegradable and garden waste, dry recyclables, hazardous waste and industrial waste directly to the municipal landfill. Of course, hazardous waste and industrial waste has to be taken care of by other facilities, and eventually some of that goes back to the landfill, but for that we can also have specialized landfills as well. But the normal standard municipal landfills, we should avoid this kind of waste. Now, what should go into the landfill then? So, which waste streams should be considered going into the landfill? Non-biodegradable and inert waste. We have learned the definitions of this earlier. Mixed waste, the waste which cannot be segregated, that has to go into the landfill. Pre and post processing rejects at waste processing, sorting and composting plants. So, in waste processing and sorting centers and composting, there are a lot of rejects which are generated which cannot be recycled or reused. So, that rejects goes into the landfill site. Sometimes all this we call the residual also. Then non-hazardous waste which is not processed or recycled, that also may go into the landfill site. What about the hazardous waste then? So, hazardous waste usually for hazardous waste we have TSDF facilities, that means treatment, storage and disposal facilities, and we have specific kind of facilities for specific kind of waste. For batteries we will have a specific facility, similarly for plastic bottles we will have a separate facility. So, for each of these different kinds of waste, we will have to generate different kinds of facilities, specialized facilities, and for large areas this is possible because we have adequate quantity of waste of each of this kind, but for small areas we can create regional facilities as well. Then normal household waste, sometimes it's like in most earlier when we have discussed collection, you have seen that usually the collection is done in form of wet waste and dry waste. So in dry waste, in certain municipalities, if they don't have a detailed processing and a sorting center, in that case, some hazardous waste remains in the waste stream, right? For example, standard like aerosol can like sprays and all, household chemicals, used batteries, contaminated containers like paints and all, this remain in the standard household waste. So what to do about them? So in that case also, even though these are hazardous waste, we put them in a landfill site, it goes into the municipal landfill, but we have to really take care that the landfill is designed in such a way so that it doesn't allows further creation of leachate, which leachate is, the water when it comes in contact with the material in the landfill site, it actually acquires all the different pollutants from that and then goes downwards and mixes with the groundwater. So that's leachate, right? So sanitary landfill with proper liners if segregation and further sorting is not possible. So we will learn about what are liners. Liners are barriers that we create below the landfill site so that water cannot pass through it, right? So these barriers are made of many materials. It could be compacted clay, it could be normal soil mixed with some amount of cementous material, or there could be some sort of geomembranes as well. So we can create barriers in different ways. So we call them liners, right? And then coming to, so some amount of, if we are designing a landfill site properly, a sanitary landfill site, in that case, we can allow some amount of this hazardous waste to go into the landfill site. Then coming to C&D waste, construction and demolition waste, so we require separate landfills or some part of the landfill. Here, let us assume that water cell, we will learn about this again in later. So, some separate landfill or within the existing landfill, one part of it or some specific cells can be reserved for this kind of construction and demolition waste. Now, why separate cell? So that we can know where we have put that kind of waste and later on we can mine it and process it. Mine it means I will take this kind of waste out and then process it. So right now I may not have a facility for processing construction and demolition waste, but in future I may have a facility for construction and demolition waste, and that's why I need to mine it out of the waste and then again further work on it. We can also use this construction and demolition waste for creating daily covers and road construction at the landfill site. Now, road construction is pretty obvious, but what is daily cover? That means every day when waste comes to the landfill, at the end of each day's operation, we also cover that waste using a layer of soil. So, instead of soil, we can use this C&D waste as also cover as well. So, that is how we can use C&D waste. So, these are the different kinds of waste stream that goes into the landfill site, and our target is to, of course, minimize the quantity of solid waste that comes into the landfill site. So, coming to the definitions, usually landfill refers to facilities used for disposal of residual solid waste on earth surface. In other words, we also call them as dump sites and all, right? Now, the problem with dump sites is, as you can see in this particular image, this is a standard dump site. You can see that this is where the solid waste is being stored, and some amount the leachate moves from the solid waste because of more and more waste that is being dumped on each layer. It presses on it, and that takes and also moisture keeps on coming in from rainfall and all. Some amount of obviously infiltrates, and this all water moves downwards and then mixes with the groundwater and contaminates it. So that is what is being shown over here. Similarly, in case of solid waste, you can see that this groundwater can actually move and mix with the surface water sources as well, and it can spread to other areas, like it can flow as per the hydraulic gradient, and then it will mix with other aquifers and all. So all this is a problem, and then in this kind of landfills, you will see a little bit of cover given at the top. So a thin native cover using local soil is given at the top, and this is inadequate, and it doesn't prevent water to get inside. So water will continuously get inside, and it will keep on creating leachate and further contaminating the entire sources of water. Now, Because we have not done proper covers and all, obviously the landfill gases which results from decomposition comes out and they will start going into the atmosphere. So all these problems will happen. Now, usually we find a lot of odor coming out of landfill gases in this kind of facilities where there is no proper engineering design. Greenhouse gas emissions, CH4 and CO2, leachate migration to underlying groundwater and surface water, breeding of disease vectors, lot of animals or lot of these insects and other disease vectors are, they are produced as well as they continue to grow over here. Then health and environmental impacts from these hazardous materials in the surrounding areas because of contamination. So all these problems happen. So that's why a standard dump site is obviously not a solution. We have to develop better facilities, right? So that is where sanitary landfills comes in. So sanitary landfill refers to engineered facility for the disposal of municipal solid waste designed and operated to minimize public health and environmental impact. So it's an engineered facility and the design is such so that the overall health and the environment is protected for this particular area. And finally, we have further developments of landfills. Like from sanitary landfill, nowadays we construct bioreactor landfills, which is of course an engineered facility as well. But the only difference is we can achieve further degradation of the waste and stabilization of the waste through increasing the moisture content. Now, this is very odd because earlier I was saying that if more moisture gets inside the waste, it will create more pollution. But here we are proposing to increase moisture. Now, when I increase moisture in the waste, the decomposition processes occur in, it increases decomposition of the waste and so on. But that also means that we will capture this moisture or this leachate and we will not allow it to go down and mix with the groundwater and use this captured leachate, and some of it we can treat it and some of it could be again pumped inside the landfill and it will keep on increasing the moisture content. So moisture along with bacteria that comes along with that particular leachate also gets mixed and that will keep on increasing the decomposition of the waste and that results in a more stabilized solid waste and more stabilized landfill, right? Stabilized means the overall size of the landfill requirement and all these things will gradually go down and it is a more compact, more stabilized surface which we can use even later. Now, this reduces the long-term threat potential through increased breakdown of organics. Of course, we said decomposition increases and sequestration of some amount of inorganics as well. So, inorganic materials takes a long time to break down in the environment and so this actually also helps to fasten it, right? So, this is the benefits of a bioreactor landfill. Now, coming to a standard sanitary landfill, which is an engineered facility, as you can see in this particular image, it shows a typical sanitary landfill. And here you can see that we have groundwater over here, and here we are not allowing the leachate to come down and mix with the groundwater. How we have done that? So you can see here a compacted soil of low permeability is given. So this is called the liner. So liners are provided at the base and at the sides to prevent migration of leachate and gas. So basically this liner, as you can see, it is at the side as well as the bottom. It prevents movement of both the landfill gases as well as water to the surrounding areas and also below, right? Then leachate management system is installed. What is that? Collection and control facility for leachate. So here you can see that above the liner we have created a drainage layer. Drainage layer is a layer which is made of gravel and other materials so that the leachate that comes directly from the top to this particular layer is captured in this drainage layer, and we have this open jointed pipes or porous pipes you can say inside this particular layer which captures that leachate, and of course we give a slope to this particular drainage layer, and because of this pipe network this leachate could be captured and then they could be brought to a particular area. For example, it or some amount of leachate also flows to this area which is created like a sump over here. So leachate collection sump, and we can pump the leachate up from this particular sump, right? Or sometimes these pipes also lead to a sump outside as well. From there also we can pump it up. So that means we are allowing the leachate to pass through, but capture it in the drainage layer, and then we can pump that leachate out, which could be further treated. So that's why a collection and control facility for leachate is required. Then gas management system, collection and control facility. For small landfills, gas management is optional, but for large landfills, we have to design a gas collection system. So we want to recover the gas. Now it is done in different ways. We will discuss it later in detail. But as you can see from the drainage layer also, we can have some certain pipes installed, and this has got some amount of material given inside this pipe so that it allows gases to enter. And then gas collection could be done at the perimeter, it could be done at different layers, right? So from different layers we can install gas collection system, and using this gas collection system we can, through passive and active measures, suck out the gas and then use it for our purposes. Then finally the final cover, which is the top cover. This is the top of the landfill which prevents rainfall infiltration. So that means we are giving a protective cover at the top which prevents water to get inside the landfill. So this is how it looks. Now surface drainage also needs to be collected, and we need to remove the runoff. So whatever water rainfall falls in this surrounding area, we should prevent it to move into the landfill site. So that means we have to create the surface drains over here. So here the water that will flow from this side, it gets trapped inside the surface drain, and we can divert it from the landfill side. And similarly, the water that is falling on the landfill side, most of it will flow down because we give a slope to the landfill surface in most cases, the landfill, this mound surface, and it will also flow back and then be captured into this surface drainage, right? So surface drainage is a big thing. That means we have to properly do a drainage network planning in this particular area, collect all the runoff, and then if this gets somehow contaminated, we have to treat that runoff, or if we can prevent contamination, we can actually collect it and then gradually let it go without flooding other areas. Then environmental monitoring. This is collection and analysis of air, surface water, soil, gas, and groundwater samples from the surrounding area. So we have to continuously keep on monitoring. Is contamination happening? There is some contamination of the groundwater? If the surrounding atmosphere, there is a lot of methane in it, because if there is too much methane, it may explode, right? So this we will keep on monitoring. And finally, once our plan period is over, that means the landfill has reached its end of design life, then in that case we do a closure and a post-closure plan. And that means that how do I complete the landfill process, and it's a long, and we also keep on monitoring all these parameters, the air, surface, soil, gas, and all this. And we also have an operation and maintenance strategy so that it doesn't, the clay layer at the top doesn't get damaged, and all this has to be continuously monitored. So we keep on monitoring for roughly 15 years, and by that time the landfill more or less stabilizes, the decomposition is more or less complete, and we can further think of utilizing this particular landfill. So this is how a sanitary landfill looks like. Now coming to the Solid Waste Management Rule 2016, we have already discussed this in one of our lectures, but we have not talked specifically about landfills. So we will just take you through the points so that you can actually go through these particular points and see that these are the things that needs to be done. And like for example, the duties and responsibilities of local authorities. That means we, as per rules, that is Solid Waste Management 2016, you can say as per law also, that landfilling or dumping of mixed waste has to stop within a specific period. That means we cannot take mixed waste to the landfill, and we have to keep on reducing the quantity of waste that goes into the landfill. So only non-usable, non-recyclable, non-biodegradable, non-combustible, and non-reactive inert waste and pre-processing rejects and residues from waste processing facilities goes into the landfill site. So our effort should be towards a zero waste landfill. That means the ULB should invest a lot of money in recycle and reuse of rejects so that we can achieve eventually a zero waste that goes into the landfill. But yeah, it will take time. It cannot happen over one day. So we have to give that time, but gradually the municipality should try to achieve this. So in addition to that, the solid waste management rules talks about existing dump sites or old dump sites and existing operational dump sites, and say that if possible we have to improve them. How we can do that? We can biomine them. That means we have to take away certain garbage from there, we have to treat it, and then we have to do bioremediation. So we have to treat it and process it and so on. And if possible, also if we cannot do this kind of biomining or bioremediation, the waste is too mixed, which is not possible. In that case, we have to give a proper cap or a proper cover to the landfill so that it allows further infiltration of leachate or moisture into the landfill, and we give as much as protective measures as possible. And also this will allow us, if we do a proper capping, some amount of gas could be also collected, right? Say methane gas could be also collected from landfill. Now in hilly areas, everything is more or less same, but in addition there are certain additional considerations. And the hilly area, because of the terrain, we cannot have landfill in a slope, definitely for obvious reason. But that means that our target should be to have again as much as processing facilities for biodegradable waste and recycling, and all these other centers can be also set up. And for non-biodegradable waste, if recycle centers are not able to be set up over there, or we don't have land, in that case there has to be a storage facility, and from there periodically this waste has to be transferred to regional material recovery centers or processing centers. And inert and non-biodegradable waste could be used for road construction and filling of low-lying areas in this hilly region. And this transfer station, as we were talking about earlier, to store and transport residual waste to a processing facility and inert waste, of course. So this goes to finally to the landfill site, and the landfill could be located around within a 25-kilometer radius, but it should be in a plain area. And if it is not available, then the regional sanitary landfill facility also could be considered. So this is this particular, after SWM 2016, every waste should be segregated, and we should only take the relevant waste streams to the landfill site. So earlier, every mixed waste used to go to the landfill, so that has to be prevented. So these are some of the criteria for site selection of landfill as notified by the government. First of all, the land should be made available for allocation of a landfill site, and also the site for waste processing and treatment facilities. And usually it's the responsibility of the town planning department to produce create land use plans and reserve land for landfill sites. So the town planning department also, when they create the land use plan, they should also consider a few aspects when they create this, when they find a location for this land use plan. So these are some of the rules which are given. Landfill site life should be 20 to 25 years. Proper construction plan and the design development should be done as per plan. A closure plan should be done in a phased manner. That means we gradually we develop the landfill in phases, part by part, because the landfill's life is 20 to 25 years. So I cannot just create the engineered facility for 25 years at one go, because it would be very costly. So we create phases, we create certain zones, we create the engineering design for that, and then we do it, and then we cap it, and then we move on to the next phase, right? But within the same landfill site. And the design is such so that at the end it's it will look like an integrated mass. For example, I have a landfill site like this. So maybe in the first phase I will do, this is phase 1. In the second phase I will do this. In the third phase I will do this, and so on. So actually this is how we should create the phases. And then landfill cells in phases to prevent waterlogging. And because what happens when I do a landfill, I will dig up a certain part of the landfill, right? So we use this soil as soil cover. Whenever garbage comes in, we have to put a soil in every daily cover, intermediate cover. We have to put this soil covers and all. Where do I get this soil? So I get this soil by digging in the same landfill site. So if I dig the entire area and create a dump of soil over here, obviously there will be waterlogging. So it's better to do it in phases so that only this zone is considered and this zone is not, dug up. The entire zone is not totally dug up, right? And In addition to that, the landfill should be 100 meters away from a river, 200 meters from surface water bodies like ponds and all, 200 meters for highway, habitation, public parks and water wells and so on. So this is given as per the SWM 2060. And landfill should be also 20 kilometers away from airport. But if I get special permission, if land is not available, I can get special permission from Civil Aviation Authority or Air Force. And using that, I can create a landfill within 10 to 20 kilometers. And in addition, 100 years floodplain, zone of coastal regulation, wetlands, critical habitats, eco-fragile areas, these are absolute no's for creation of landfill sites. So this kind of a land area has to be prevented. Finally, we have to create buffer zones if the amount of waste that we deal per day is more than 5 tons per day. And temporary storage facility is also required in the landfill site, so that in case of stoppage of operation because of many reasons like emergency, natural calamities, non-operation of waste processing centers, then in that case this facility has to be there which can temporarily store the waste before it moves into the landfill site. So what are the different kinds of facilities that should be provided in the landfill site? First of all, entry should be monitored and entry should be controlled. We don't allow unauthorized access or movement of stray animals inside that landfill site. Similarly, all records should be maintained. Waste received, processed and disposed, all these records should be maintained and we should have an office for that. Then in addition, we should have provision for weighbridge, fire protection equipment, drinking water, sanitary facilities. Nighttime working should be allowed and that's why there should be adequate lighting. Then safety and provisions for the health inspection provisions for the workers, so there has to be certain centers for that. And finally, provision for parking, cleaning and washing of transport vehicles and treatment of the water that is generated from this particular activity. So these are some of the facilities that has to be provided for landfill site. Finally, criteria for specification of landfill operations and closure. That means how do I operate and how do I close the landfill? So we have more or less discussed all this. We have to compact the waste before I put it inside the landfill. So it should be done by some heavy compacting equipment like bulldozers and all. We press the garbage into this particular site. But problem is, if in case of rainy areas, this kind of compactors will not be able to work. So we have to make alternative arrangements. Maybe I do the compaction earlier through use of compactor vehicles and then bring the compacted waste only to the landfill site. So landfill should be covered at the end of each day, 10 centimeters soil or inert C&D waste as we have discussed earlier. Before monsoon, we should put an intermediate cover. A more thicker cover is provided so that water doesn't get inside the waste, and it's around 40 to 65 centimeter thickness. And the other things we have discussed like drainage to divert runoff, and finally a barrier cover at the top. Now we have discussed about the reason for providing barrier cover, but here some specifications are given in the rules. For example, it should be a 60 centimeter clay or amended soil. Amended soil means a soil mixed with cementous material with permeability coefficients less than 1 into 10 to the power 7 centimeter per second. That means it should not allow water to pass through. Plus a drainage layer on the top, 15 centimeter of the barrier layer. Why this drainage layer? Because at the top there is a vegetative layer of 45 centimeter. Now this vegetative layer is given so that we can allow plants to grow, and this plant actually keeps the soil held by the roots, which prevents erosion. And that's why we have to put a topsoil layer. Now because we are putting a topsoil layer, there has to be a drainage layer below it so that the water that passes through this soil has to be drained out via the drainage layer. And below the drainage layer is the barrier layer so that further the water doesn't goes down. Similarly, for old dump sites or old dump sites, we also have to have certain considerations. So we have to do biomining and waste processing as we have discussed. That means as wherever possible we should have to do that. And in case if in that case whatever is after processing the waste, again some waste will go into some waste will be recycled, some waste could go to in the fertilizer or in the composting plant. But whatever remains goes into the new landfill site, or in the same site we can have a new facility design which is engineered, and the rest would be capped, right? Or we should put cover on that particular remaining waste that is there. The capping could be done with solid waste cover or solid waste enhanced with a geomembrane. We will learn about these designs later on. Geomembrane is a plastic layer sort of, which along with a soil clay layer, we also put this plastic layer which prevents water to pass through. Capping with cut-off valves and extraction wells, and so that we may need to pump and treat the contaminated groundwater because there is no bottom liner in this particular case. And finally, other measures for reducing environmental impact also needs to be considered. Now, in general, the new landfill design specified by Solid Waste Management Rules 2016 talks about prevention of all sorts of pollution. So, first we have to create a proper drainage system for draining the stormwater, and so that we have to prevent it to mix with the leachates, and of course this will prevent the pollution of surface waters, and it will allow because during certain rainfall events there may be some amounts of flood that happens, so this could be prevented. And we have to create non-permeable lining system at base and walls, liner of composite barrier as we discussed, 1.5 millimeter thick density polyethylene HDPE. This is a geomembrane, and we can call them geomembranes or geosynthetic liners. And this is above another 3 feet of or 90 centimeter of soil, which is clay or amended soil, having low permeability of 1 into 10 to the power 7 centimeter per second. So I have got a soil layer and then a geomembrane above it, right? So this is 3 feet and this is that geomembrane of 51.5 mm. So this is the design of the cover, right? Design of the this liner. So there are different designs. We will discuss that in detail later. We should be very careful about the water table at least 2 meters below the base of clay or amended soil barrier layer. So below the bottommost liner, there could be multiple liners below. So let us assume there is one liner. So at least a 2 meter distance has to be maintained with the groundwater table. So otherwise what happens? There is some leachate, whatever liners you give, there will be some amount of leachate which goes down. So we create an additional barrier. Then leachate management collection has to be done, which is nothing but collection and treatment of leachate, and some could be reused, and otherwise it has to be released to the sewerage network after treatment, of course. But it cannot be directly let out as as runoff to drains, streams, lakes, or ponds. And in case it somehow gets mixed with the runoff, the entire mixed water needs to be treated. So that means we have to be very, very careful about both leachate as well as the surface runoff in site areas so that they don't get mixed together, and if they get mixed together, we have to make provisions for treating them. Finally, these are the criteria for water quality monitoring and ambient air quality monitoring. Water quality, of course, groundwater quality at periphery of the landfill to a distance of 50 meters has to be periodically monitored, and particularly in summer, monsoon, post-monsoon seasons. And we have to have a baseline data on groundwater quality so that we can understand what kind of contamination is happening. If I get the baseline, then I can compare the current observation with the baseline. And these are some of the standards. As you can see, we measure for arsenic, cadmium, chromium, copper, cyanide, and so on. Similarly, for landfill gas or air quality monitoring, we have to have a landfill gas control and collection system. This reduces odor, off-site gas migration, protects vegetation, and geomembranes enhances gas control and collection. And we have to make sure that the total concentration of methane gas, which is CH4, this is a result of the decomposition process, methane and CO2. These are both greenhouse gases, and below 20, it should be below 25% of the lower explosive limit. Why? Because methane gas is highly flammable, and in case you are not taking care of that, it may get accumulated, and it's also heavy. So it will remain there, it will get accumulated, and it may actually create an explosion, and actually that may lead to loss of human lives. So that's why we have to be careful. Utilization of so either I can use this for creating power, we can burn it in a power plant, we can create power out of this gas, or if we are not able to, if the quantity is not adequate to set up a power plant, in that case we need to flare it or burn it occasionally. So we have discussed this earlier as well. Gas is not allowed to escape to the atmosphere or for any other illegal use. And in case flaring is not possible, possible for some reason, then we allow passive venting of the gas. Means gradually we allow the gas to vent in a very slow pace, right? So, in addition, ambient air quality standards are monitored. As you can see, these are the ambient air quality standards. These are standards created by the Central Pollution Control Board, and because it's considered as an industrial area, these are the standards that we consider: sulfur dioxide, nitrogen dioxide, particulate matter, PM 2.5 and PM 10, and carbon monoxide, ammonia, and benzopyrene, and so on. So, these standards are given, and the levels monitored should be within acceptable levels. So, some other criteria for pollution at landfill site, plantation at landfill site. So, as we discussed, the top cover should be done, and after that we can have a vegetative layer at the top, and the plant selection should be done so that locally adopted non-edible perennial plants resistant to droughts and extreme temperature. Plant roots should not penetrate more than 30 centimeter, because if it penetrates, it will create holes in that top burial layer, and because the holes are there, then water will percolate. So, we have to make sure that the trees have very shallow root systems and ability to thrive on low nutrient soil. So, these are the criteria for selecting these plants, and usually in addition to the plantation, which helps in prevention of erosion and all at the top cover, we also have green belts around the boundary of this kind of site. And finally, for post care, that is post-closure care, once the landfill operations are done, then we have to, cover it, the final cover, the vegetation layer, all these things are put. But at least we have to keep on monitoring this for the next 15 years. Because this is the time when the decomposition will gradually happen. There is subsidence of the landfill, and because subsidence, there cracks may appear, which may allow water to get inside, that will create further leachate. And so, integrity and effectiveness of the final cover needs to be checked from time to time. Monitoring of the leachate collection system, groundwater, landfill gas collection system, this has to be done. And after 15 years, we can consider human settlements, or for any kind of use, like it could be made into a park or something. But obviously, we have to first check for emission, leachate, and soil stability of this particular site, and accordingly, we have to take a decision if we should allow further human settlements in this area or not. So, these are the references that you can consider. And all solid waste, to conclude, all solid waste disposal plans, including designs of landfills, are prepared by following the directions given in the Solid Waste Management Rules 2016. And as you have seen, we have discussed the rules today. So, these are rules. So, every area has to follow this kind of rules which are given. So, thank you for this, and we will discuss this in detail later.